Good morning, students. So today we're going to solve question 8 from grade CSE 2022. The question states that a box contains 5 balls of same size and shape, right? 3 of them are green, okay, 3 of them are green colored balls and 2 of them are orange colored balls. Balls are drawn from the box one at a time. If a green ball is drawn, it is not replaced. Okay, that is a very important information that they have given to us, right? This is information regarding the event, right? Event what? Event green, right? Event that a green ball has been drawn, right? If an orange ball is drawn, it is replaced with another orange ball. This is about the event orange. Okay. Yes, first ball is drawn. What is the probability of getting an orange ball in the next draw? Okay, so first ball is drawn. That part of the question has been done. So first ball has been drawn, and with these rules of the events being present, right? With these rules of the events being present, we are being told that what is the probability of getting the orange ball in the next draw, right? So we have to consider the possibility of the first ball being of green or orange, because the second ball being drawn depends upon your first event, right? It depends upon your first event. And what is the probability formula that you must have heard about, that is used when a event has already happened and we are trying to find the probability given that a certain event has already happened, right? It is called the Bayes theorem, right? If you do not remember Bayes theorem, I would highly recommend that you go and watch a video on Bayes theorem on YouTube, because it is fundamental to this question, right? Basically, I will give a short note on this. Basically, this expression means that the probability of event A happening given that event B has already occurred, right? And P of A intersection B is basically A and B happening simultaneously, right? Okay, so how does it make sense that B has already occurred and we are considering B A intersection B? No, this probability is not found with B event already occurring, because if that were to be the case, we would have written P A intersection B given that B has already happened. Don't interpret everything like that. This probability is for when B has already happened, but this probability is for when A and B, both of them are not happened, and we are considering possibility directly, right? And PB is that directly possibility of B happening, probability of B happening, right? That is basic funda of Bayes theorem, right? It is true, it applies, and it can be very intuitively also understood, right? So I would highly recommend that you go and understand this before trying to attempt this question. Now this part we have, let's take this denominator over here and take it to the left side, right? Because we are going to use it in this question in that manner. So let's do that. So we will get P A intersection B is equals to what? P of A given that B has already happened times probability of B, right? This is what you're going to get from P A intersection B. Now I will give an expression for that. Let's say that G1 basically represents that the first drawn of the ball is a green ball. This is one event, right? Likewise, G2 represents that the second ball that has been drawn is a green ball. Likewise, OR1 represents that the first ball that has been drawn, it represents the event that the first ball that has been drawn is orange, and OR2 represents that the first ball that has been drawn is basically the second ball that has been drawn is OR2, right? And what exactly are they wanting us to find? They are wanting us to find what is the probability of getting an orange ball in the next draw, right? So they are wanting us to find the probability of this one, right? OR2. But here is the basic funda that they have not mentioned. That is because they have not mentioned it, and that's why we have to consider it more holistically, right? If they have already mentioned that the first ball that was drawn was green or it was orange, then it would have been much more straightforward. But because they have not mentioned that and we are considering possibilities, that is probabilities, right? So we have to consider all of the possibilities for it to be comprehensive. Otherwise we are just not being thorough, and the answer that we're going to get is not going to be the correct one, right? So for OR2 to be considered, both of its predecessors must be considered, and their probabilities have to be summated, have to be added together to get the total probability of this event happening, right? So what would that be? Probability of this thing happening and then this happening, and the probability of this happening, and then this happening. These are the things that we have to find. And how are we going to represent that this and this happened simultaneously and this happened simultaneously? Very easily, by this kind of expression basically. Let me write that here too. Okay, so just take this over from here and just take it to the next page, right? And from there we're going to directly try to find it, right? So the probability that we're trying to find is the probability of G1 intersection OR2 plus probability of OR1 intersection OR2, right? This is the answer. This is basically is going to be our answer, right? And let's apply the Bayes theorem, and that was presented in this format to simplify this. And how would you do that? Extremely simple actually. Just first I will basically, the assumptions that are required for this is already presented in the question, and it's a good question, but obviously it's a simple one, right? So let's represent it like that. So this answer is going to be equal to what? P of orange. First we are going to take the first one, that is the ones which have the subscript as 1 are the given parameters, right? This B is the given parameter, right? Because it is used in this manner, right? So we are going to take the G1 portions of this, and we are going to take the probability of them outwards, right? First. So that, with that being said, I am going to take it like this: G1 times your probability of OR2 given G1. It would be like this, right? From Bayes theorem we get it this directly, plus P of OR1 dot P of OR2 given that OR1 already happened, right? With these being present, what are the things that we already know? Can we find these values? Yes, obviously we can. Why is that so? Because in this they have given us that there are 3 green balls and 2 orange balls, and all of them have the same size and shape, and they were taken out from a box, right? And we don't really know what was we don't have any way to guess, right? So it is totally upon chance, random, right? So we can directly apply the basic meaning of probability to directly find that possibility. And what is that going to be? Let's see. This is the basic information with which we are going to come here again, and then apply this information to get our answers, right? So with this information being present, I would say that P of G1 is going to be equal to what? The number of green balls in the first case scenario by total number of balls, that is going to be number of green balls plus number of orange balls, right? And what is that going to give us? That is going to give us extremely simple 3 by 5. Likewise, the probability of OR1 is going to be equal to what? 2 by 5, right? Very simple, very straightforward. This, I don't think that there would be any doubt on this. It's very simple. If you don't understand this, then probability concept you are lacking. You must study some of it. I would highly recommend that you go through some YouTube videos over reading through the books, because reading through books is a much slower process compared to this visual kind of interface that has been provided to us. Thank God for that. And use the resources that you have properly, man. You don't have infinite amount of time, right? So with that we have the probability for this thing and this thing. Now we have to find these, right? To find these, how can we find this? We need to know the green balls and orange balls that would be present given that this event has occurred, right? So for that, are there any rules that we know of that will give us the exact number of balls of both types? Yes, we do have actually. And what is that? Let me show you. In these lines they have given that if a green ball is drawn, right, if G1 occurred, then it will not be a green ball would be reduced, right? So if G1 had occurred, then your green balls would be 2 and your orange balls would be 2. But if orange 1 has occurred, then green balls would be 3 only and orange balls are going to be 2 only. So nothing will change in this case. So this is the information that they have provided to us, and we can directly use this information to find these probabilities, right? So let's take that information over here right? And with that try to find these probabilities, right? Very simple actually, but obviously this requires that your concepts be very clear. And how will your concepts be very clear? By practice. There is no other way. It's mathematics. No, mathematics, more discussions and analysis, and practice is basically what leads to better flexible knowledge. No, because you must be able to apply the knowledge that you have, right? So how are you going to find this? Given G1 has occurred, so G1 has occurred, so the ball ratio, the number of balls of both types are going to be 2 by 2, 2 and 2, right? And we are trying to find orange balls ratio, or orange balls possibility, right? Probability for orange ball being there taken out in the second attempt, right? So that is going to be equal to what? 2 by 4, that is 1 by 2, right? And what is the probability for this event, right? That orange ball has been drawn both times, right? That is going to give you basically 2 by 5, because this is the ratio that has been of the balls if orange 1 was the first event that has occurred, right? So with that being present, let's write that over here also, right? So this thing is equals to your orange to 2 by 5, right? This with we have now calculated all the terms values that we have to know to find the answer. Directly apply these values to this expression and you can directly find the answer. The answer is going to be equal to your PG is basically going to become 3 by 5, right? So 3 by 5 times what? Times this thing, OR2 G1. OR2 G1 is basically 1 by 2. Okay. And then you have POR1, that is going to give us 2 by 5. 2 by 5 times your POR2 given OR1, that is 2 by 5 again, right? Let's simplify this and basically find our answer. That is going to give us 3 by 10 plus 4 by 25, right? And that is going to give us 1 by 5. I'm taking common basically, and this thing giving me 3 by 2 plus 4 by 5, right? That is going to give me 1 by 5 times 15 plus 8 by 10, right? And that is going to give me what? Basically 23, right? 23 by 50. Is there any one of the options that match this answer? Let's see. 23 by 50. Yeah, so D option matches this answer. So that is going to be your answer for this question. It is a bit of an understanding of probability, at least till the concepts that were discussed till 9th and 10th must be very clear to be able to solve this question. It was a good question, and I hope that you must have been able to solve this question independently, and this video only serves as a validation. Other than that, have a very good day, and I will meet you in the next one.